Okay, welcome to part 2 for module 2. Now, in the previous part, we were talking about real objects, and we said that a real object is presented by 11 bits for the exponential, 52 bits for the Mentessa, and 1 bit over here for the sign. In total, it is 64 bits. Now, what happens if the number is bigger than 10 to the power 38? Or smaller than 10 to the power minus 38, or minus 10 to the power 38 and minus 10 to the power 38, or it is smaller than, or it is between minus 10 to the power minus 38 and 10 to the power minus 38, which is the small values over here. So here we have what we call an overflow, and here what we have an underflow. Here the number is too big to be displayed or saved in any memory location, and here the number is too small or almost equal to 0, so that it will be displayed as a 0. So here it's considered our infinity, here it's minus infinity, and this range over here is considered our 0. So the overflow, the exponent is too large, not enough bits to be represented. For the underflow, the number is too small, so not enough bits to represent the negative exponent. Now, how do we represent a number? A number is either presented in the different ways for the significant notations. These all represent the same value. So it's either 0.12 multiplied by 10 to the power 11, or 1.2 multiplied by 10 to the power 10, or 12 multiplied by 10 to the power 9, or 12 multiplied by 10 to the power 9, or 12 multiplied by 10 to the power 9. The difference between these three, this one has an extra significant digit. This one has the E small with a fraction. Here, this one without the E small, it's a capital E. Now, when it comes to characters, we deal with the ASCII characters. Okay, we deal with ASCII characters to represent our characters. So basically, each character on our keyboard will be represented as an ASCII character. So if I go here for Google and I say the ASCII code table, so we are going to find the ASCII table in multiple images. And let me show you one of these tables. Okay. So the ASCII table is basically what everyone, this is the ASCII table. Now each character, each letter, you see here, each character and each letter will have an ASCII value from A small, which represents 61 hexadecimal or 97 decimal, down to Z, to A capital, to all the characters on your keyboards. Now, the idea is this is a standard. So if you buy a keyboard from China and use it in Oman, or you buy a keyboard from the US and use it in Oman, all of them will have the same standard because this is called the ASCII standard. It represents the data. So these are how the characters are stored. So when I press A on my keyboard, this ASCII code will be stored in the memory representing A. When I press B, this is the ASCII code for B, and so on. So this is how characters are represented within our memory as numerical values. So the character literals are always enclosed in single quotes. So if I say character C is equal to A, single quotes. So here, character C is equal to A. So here, this variable, I'm storing in it A capital. How do I enclose it? I enclose it in single quotes. We have special characters, anything with backslash. When you see a backslash N means a new line. A backslash T means a horizontal tab. A backslash V means a vertical tab. A backslash B means a backspace. So if I say cout, okay, cout, and then between quotations, I say /n, this is C++ class, quotations, semicolons. When I go to the display screen, /n means leave the first line, leave the second line, and we are going to write over here. Okay, so /n means a new line. /t means a horizontal tab. Vertical tab and backspace, we are not going to use them much, but /n and /t, you need to know them very well because we are going to use them a lot within our study. When we want to declare a string, we use double quotes. Okay, when we want to declare a string, we use double quotes. When you want to display a character, you use a single quote. So double quotes enclose a string is enclosed within double quotes, and it can have escape characters like here /n. The answer is means go to the next line and type the answer is. A /n is equivalent to end line. We sometimes use end line. I'm going to show you this later on. We sometimes use end line for that. Now, this is you need to differentiate. This is a string and this is a character. Although both of them are the same, but this is a string because of the double quote, and this is a character because of the single quotes. Now, Booleans is like true or false, 0 or 1. Okay, so you have only two values, and mainly it is used for digital systems and for Boolean expressions, which we are going to see them when we talk about operations and expressions, especially in if statements. So it is either true or false. Then we have the identifiers. How do you create your identifier? Identifiers, like I say, integer a is equal to 5. A is considered an identifier, object identifier. So the rules are, it must not be a keyword. You cannot use integer, if, while. These words are preserved words. You cannot start. You must start with a letter or the underscore. You must start with a letter or an underscore. You cannot start with a number. Okay? You cannot start with a number. Usually, use meaningful identifiers. So if I'm calculating the area of the rectangle, so I'm going to say integer height, sorry, integer, here we use length, integer length is equal to 5. Of course, don't forget the semicolon. Integer width is equal to 2. Then integer area is equal to length multiplied by width. So if you read this equation, you are going to understand what we are calculating. The same, if I did the same and I said integer L, integer W, integer A, it's very difficult to know what's going on there because you don't know what these literals mean. So it's better to use meaningful identifiers. Now, when it comes to identifiers, it's better to start with always a small letter, and if you have two words, the second word will start with a capital letter. So, of course, C++ is case sensitive. Case sensitive means small letters, capital letters are different. So variables with the small letters and capital letters are different. So if I write this sentence, sorry, this is the first, or let me type it better. So let me come here and say this is the first time I or time to read without spaces. So if you come and you see this message or this sentence, okay, if you see this sentence, you can read it, okay, because I capitalized the beginning of each letter. The same one over here, sorry, the same one over here, if I came and just changed the settings of this into lowercase all and ask you to read this one. Now it becomes difficult, okay? It becomes difficult. So make it a habit. You capitalize the beginning of each word. So it's this one, it's easy to read. It is the monthly electric charge. If you are declaring a constant, you always declare it as all caps, capital letters. Constants, always capital letters. A constant is always declared with capital letters. Now, there are three kinds of objects. The first object is a literal, which is a variable declared, not named. You are going to use it, and that's it. If I say cout 5 or cout C++, this literal is not saved anywhere. We are going to display it, and it will be deleted immediately. The next type is a variable where it's stored in the memory, and you are going to use it. So if I say integer a is equal to 5, then cout a, I'm going to display what's stored in A, and A will remain. Okay, values can change, but we always save them in the memory. The third type is constants, which are named objects, but the values, they do not change. Like if you are declaring pi, if you are declaring the speed of light, these constants, usually we declare them once in our program and do not change them. And here, examples, we have some literals, we have some doubles, we have examples on characters, and we have examples on strings. I think this is, okay, this is declaring the constants. When you declare the constant, you start with const, which is short for constant, const. The type of the constant, is it a double, is it an integer? Then the name of the constant, and remember all caps, and you should give it a value. You must initialize your constant. You must initialize your constant because it needs to be initialized. You cannot change the value of the constant within the program, and it must be initialized in the beginning of the program. Now, the reason to use constants, it improves the readability of your code, and also it facilitates the program modification. Like in our previous example, when we said the hourly rate is 5 reals, let's say they want to increase the salaries for the employees, they will just change the 5, let's say, to 7. Okay? And also it's a good programming practice to use constants. So it's not only about easiness, but it's also important to have good programming practice. So variables give names to memory locations, and they are referred to as objects within our program. We need to declare them. We say the type of the variable, then the name of the variable. You can initialize it or you cannot initialize it. It's up to you, but usually we initialize it. If it has no value, we give it a 0 value. So examples of variables: integer age is equal to 18, double GPA is equal to 3.25, character letter grade is equal to A, Boolean OK is equal to false. These are all different types of variables. So this is all for our week 1 or week 4 in module 2. Hope to see you all soon. Thank you for watching.